Hi, I'm Whitney Espich, the CEO of the MIT Alumni Association, and I hope you enjoy this digital production created for alumni and friends like you.
Good afternoon, everyone. My name is Frank Kromowski, and I'm the Associate Director of Regional Programs with the Alumni Outreach Team. On behalf of the MIT Alumni Association, it is my pleasure to welcome you to today's program, a talk by Professor Martin Culpepper. Martin Culpepper, Professor of Mechanical Engineering, is MIT's first Maker Czar. He leads MIT's effort to upgrade legacy spaces, equipment, introduce new technologies, create new campus maker spaces, foster maker communities, and collaborate with peer universities, alumni, government, and industry. Professor Culpepper is the recipient of an NSF Presidential Early Career Award, 2 R&D 100 awards, a TR 100 award, and a Joel and Ruth Spira Teaching Award. His areas of expertise are in precision engineering, manufacturing, and thermofluid systems design. Professor Culpepper.
Well, I'm very happy to be here today. I wish we could have all met in person. Everybody that's seen my talks knows that I love to bring hardware, plus I love to bring students. So it's my hope sometime in the future to be able to supplement this with a video we can share with people, some of the students and the hardware that they've built, and them explaining the hardware that they've built. I was very happy to join you all today to talk about the work that the class of 1960 has enabled on campus. We're going to talk about maker spaces today and the changes that we've been making on the MIT campus. I've got a few slides to show you. I'll talk for maybe 25, 30 minutes and then stop for some questions.
And on that note, anyone who does have questions as we're going throughout Professor Culpepper's presentation, feel welcome to insert those into the Q&A, and I'll go ahead and facilitate the asking of those questions at that time. Thank you.
So I've been very happy to be a class of 1960 fellow because this has enabled us at MIT to do 3 very important things for our students. We've been able to provide new opportunities for them to grow personally, to have ownership over some of the activities that they conduct on campus, and to show leadership not only amongst their peer groups, but actually with the administration at MIT. So we'll talk about that topic today. Also supporting innovation and entrepreneurship with maker spaces. A lot of strides that have been made on campus, a lot yet to go, and the gift from the class of 1960 enabled us to set the foundation for the future of making and innovation at MIT over the next 10 to 20 years. So we'll talk about all 3 of those today. This might look familiar to you all. Maybe 10, 20, 30 years ago, this is what people thought of as the place at a university where you go to build things. And if you look in this space right now, you'll see there's one person way in the back, and that's the technician. These are not the kind of spaces that students want to come to, right? I think it's very telling that most of the spaces like this typically sit empty for the vast majority of the time that they're open. This is not the kind of space where students want to go and hang out with their friends, not the kind of space where they want to socialize, where they want to do innovation. It's been my job on campus to make spaces where the students want to do that. These spaces all have the same sorts of equipment. They have the same sorts of goals in terms of being able to make things. The key difference here is that these students have ownership in running the spaces and making decisions about what happens in the spaces, in training each other in the spaces, and it's more community-centric. And that's a very difficult thing that a transition at MIT's had to go through, is a culture shift. And people that have tried to do culture shifts before know how difficult that can be. A shift away from more of what we call the babysitting model, where technicians watch over students all the time, to a model where you trust the students. And after all, these students, they're not children, they're adults. So my job over the last 3 to 4 years has been able to enable this change at MIT. And there are a lot of benefits that come from that, and I'll talk about those today. So my name's Marty Culpepper. MIT's Maker Czar. That's a very modest way of saying I have absolutely zero power at MIT. The title Maker Czar was originally established just to mean somebody to be a steward of making at MIT. What I do is I don't run all of MIT's making. I actually work with other maker spaces, machine shops, in addition to the few that I run, just to make things better for the students. And so there are a lot of activities internally at MIT where we do this, and then there's some activities external at MIT where we work with industry and government to make this happen. But we're going to focus today on what happens at MIT. It'll come as no surprise to you all that at MIT, the motto mens et manus, mind in hand, is applied everywhere. So in the research that we do, it's applied in entrepreneurship. So these two, I like to call them the Harry Potter twins. Very clever device they invented that you carry along with you, and you set it up underneath it. Fits snugly in a coffee cup, for example, you get from Starbucks, and keeps it warm. And then when you're done with that coffee cup, you throw it away and you keep the device, throw it in your pocket. All of that made at MIT, and eventually they went out after building the first prototypes at MIT and created a factory down in Mexico to run that. There's art and personal making.
Solving in 3, 2, 1.
And then crazy kinds of making. I don't know if you've all seen this video. That's an amazingly fast way to solve a Rubik's Cube. The only way I've ever solved one of these Rubik's Cube is if you hit it hard enough with a hammer, it breaks apart and then you can reassemble it properly. This is a great project for students to be doing because they learn a lot about mechatronics, control, how fast you can make things move. And they actually had to slow this device down so that it didn't cause a Rubik's Cube to fly apart. There are teams and clubs where students build things. Making is pervasive at MIT. And we also have a lot of social events where students get to come and participate just for fun. This is Make or Break. It's run late in the spring semester typically. And what you see here is a community project where everybody that attends that fair gets to weld onto a statue their own digit of pi. And so that'll be a community project that continues on forever. This is one of the reasons why we have so much space at MIT that's devoted to the hands-on. So there's about 2.5 football fields right now, and we'll be adding more space to that. To give you an idea of what that looks like relative to campus, this is the part of campus, the Sloan School's over on the right. This is 77 Mass Ave here. This is where we do a lot of our teaching. That's a football field on the left-hand side. That's what 3 football fields looks like. It's not an insignificant investment. It's a great investment because this is one of the things that's unique about MIT and enables us to have impact. I want to talk to you now about what we've been doing at MIT that is a huge change. It's a fundamental change in the way that we have students doing making, innovation, and entrepreneurship on campus. This is the model that pretty much all schools have followed for the last 20 to 30 years. It's a helicopter parenting model where you go into a facility, you want to build something, you probably need to know the technician's favorite donut just to get permission to go in there. And then once you get in there, they babysit you the entire time. And that's ineffective for 2 reasons. You know, MIT students are independent and they're adults, all right? They need to be trained, held accountable for being safe, but they don't need to be lorded over. The second problem with that is when you're babysitting somebody, really it's a false sense of security. If there is an accident that happens, all that babysitter is there, all they're going to be able to do is to react to the situation. So people tend to think babysitting makes things more safe. We've actually shown that that's not the case. So what are we doing about this? Well, we've gone through in typical MIT fashion and tried to understand what are the problems, what do the students need? And so we've run surveys where we ask them about a variety of different aspects of their making, right? So we find out how much they make, we find out when they want to do making, and we even find out who they want to learn from. And this was a huge shift on campus. Most people thought the students would say, you know, almost 90% of them would say, well, I want to learn from a technician. Some of them do, but not all of them do. And it's our job on campus to find the best way for our students to be able to learn. There are certain instances where it's better to learn from a peer. They feel more comfortable, and they'll take the time to learn in that instance versus being scared, for example, to go talk to a technician. That's led us to the following change in the way that we do making on campus. We've got spaces now that are either fully student run or they're partly student run. Now, the first thing that people tend to react to and say, is they say, well, that's not possibly going to be safe. That's not true. And we've shown that over the last several years. This space, the Deep, is one of the most recent spaces. We actually opened this with part of the support from the class of 1960. It's called the Deep. The students wanted to call it the Deep because they have more of the sophisticated technology there, and it just happens to be in the basement in one of the buildings. So deep means 2 things. It's deep underground, but it's where you go to learn, deeply learn about how to make things. It's staffed by about 40 student mentors in addition to one technician that helps to facilitate. And we have hundreds of students that come through there every semester. There's a Metropolis, which is the precursor to the Metropolitan Warehouse Makerspace. I'll talk a little bit more about that later on. But again, this is another one of those spaces. It's part-time staffed by the students. And you know, what that really does is it enables us to have these spaces open after 4 p.m. The technicians have to go home, they have lives, and the students, we find from most of our surveys, love to do most of their building on the weekends or between 4 and 10 p.m. And so this basically makes it possible to take all this square footage and put it to use through many more hours during the day. There's the Maker Workshop. This was one of the first student-run maker spaces that we had start. This is run by about 60 student mentors. Actually, it's 90 now. And all of these students volunteer their time. They're not paid. They volunteer their time because they want to be part of the community. They want to have ownership in the space, and they feel compelled to help out their peers. And it's worked out very nicely for MIT. And then in partnership with the Sloan School and the Martin Trust Center, we started a small makerspace over there to help support their rough prototyping that they do for innovation and entrepreneurship activities. And that's been a wild success as well. In all of this, there's a lot of benefit. So the students that work in these spaces, they love these spaces because they feel more comfortable. It's got a community, so they're more likely to want to go there. And that community adds to this whole thing the ability for people to intermix more and to ask questions. It's also great as a recruiting tool because students come in there and they work, they feel grateful because they've been given the experience to be able to have access to all the equipment and the knowledge. And it's almost like that's the farm team methodology. The students join in. Now, for the people that volunteer, there's also a benefit. This is some data that was taken when we asked the students, you know, relative to other things that are important to you. For example, when you're going to go out after you leave MIT, what kind of an impact has this had on you? And that experience of volunteering and taking on responsibility has had, for the most part, a positive impact. Although we see up in the upper right-hand corner, we do have some of these mentors maybe that are a little too zealous and they spend too much time in the makerspace. And sometimes it can have a little bit of a negative effect on their grades. That was a huge thing at MIT, making it possible for the students to feel like they mattered in terms of, you know, their own destiny, that they could help to decide what happened in these spaces, that they help to actually fund the spaces, that they teach each other. That's a huge change from the way that things used to be done more globally across the MIT campus. That leads us into what is the future of making at MIT. Well, we've taken a survey in the last few months, and I want to point out on the left-hand side here, 4 maker spaces that are highlighted by the arrows. These are the 4 student-run maker spaces. Now at MIT, we have over 30 of these different maker spaces, and we asked the students, where do you go to make things? Now the Papalardo Machine Shop was #1, but it's #1 because it's, you know, houses some of the largest classes and they only support classwork. So if you disregard that and you look at where do the students go to build for any reason whatsoever, it could be classes or research, you know, spaces that enable them to do anything they want. The Maker Lodge, which is part of Metropolis, the Deep, and the Maker Workshop are in the top of the 30. They're in the top like 10–15%. Now the Martin Trust Center ProtoWorks is a much smaller space. It's actually the smallest maker space we have on campus. I think it's probably 250 square feet. But even at 250 square feet compared to some of the other spaces at 5,000 square feet, it's still punching far above its weight. So what does this tell us? Well, it tells us that this student run and student ownership, it's doing the job. It also tells us for the purposes of making it MIT, for certain purposes at MIT, this is the model that we want to move forward when we open up the new Metropolitan Warehouse Makerspace. And I'll talk about this in a little bit. So this has been a huge success. Maker Lodge, the Deep, Metropolis, those were all supported in part by the class of 1960 gift and enabled us to ramp these things up over the last year and a half. Within that time, they've moved up to be the top spaces on campus versus all these other spaces that have been open for 10+ years. It's a good success story. That leads me to the Metropolitan Warehouse. The Met Warehouse is going to be the largest academic makerspace in the state of Massachusetts. It's going to be the largest, obviously, on MIT's campus, and it's going to be the best in the world. It's my job to make it the best. And what's going to make it the best is going to be this combination of students and technicians that run that space, but then also it supports entrepreneurship, right? So in addition to all the other sorts of things that makerspaces typically support, classes, research, personal making, it has a specific focus on innovation and entrepreneurship. And the reason for that is, at MIT, we're supposed to have an impact. This is one of the primary vehicles to be able to do that. And one of the ways that we have impact is we realize physically the ideas that we have. So we need a space on campus where the students can go to realize their ideas. This is a rough floor plan. It's a little dated, but it'll give you an idea of what this space is going to look like. And to give you an idea of the size, my second midlife crisis is a Ducati Monster. So I've got this in the bottom, and I think in terms of Ducati units. So this will give you an idea of how big that space is. It's got all the things that the students would need to be able to create the things that they want to create. We've actually added in wet lab capacity, which is not shown here, wet lab capacity and bio capacity at the same time. But the question arises, this is another unique thing that we were able to figure out with help from the class of 1960, is it's great to build these spaces, and there are building codes that say these spaces should be accessible to people, you have to have ramps, etc. But that's only a part of the story of making it accessible. If you build something so that physically the structure makes it so somebody can get in, but it's not a welcoming environment, and you don't actually go through and configure the machines and the benches and all the things that a person would have to work with, if you don't pay attention to those details, it'll be very difficult for some of the members of our MIT community to be able to use this. So folks, for example, in a wheelchair, people that have limited vision, it's our job to make sure that these folks have the same sort of opportunity that everybody else on campus does. So I'm going to play a short video here that gives you an idea of some of the work that we've been doing. It started in the last year. This is being integrated to some of the student-run maker spaces that we have right now, and it'll be integrated into the Met Warehouse. Our goal, well, actually I shouldn't say goal, what we will do is that space will be 100% accessible to every member of the MIT campus, not just physically, but in terms of programmatic and then the way that they can use machines.
One of the great things about the maker community is that people are used to questioning the things that they would normally think would be impossible. Maybe they're surprised, but that someone is, using a mill or a lathe from a wheelchair, and they're kind of like, oh, that's interesting. But it's never like, I don't see how that's possible, and I don't think it is possible. Whether or not someone feels welcome is much more a function of the little things that people do to include you in the space. The attitude that people have around you, that's huge. So you can really, it's very easy to tell if someone is open to having you in the space and figure things out at your own pace and stumble through some things. In many ways, the culture of making, of engineering something fits right in with the way that someone who has some physical challenge or whatever the challenge is, when you're always kind of problem solving your way through your life, you're constantly iterating and thinking of new ways to do things, and that is exactly, it's a good fit in that way.
That was Theo. Theo is one of the volunteer student mentors in the Deep. He's one of the best mentors that we have. He's fantastic at teaching, but he's also been instrumental in helping us understand from a different perspective how spaces have to be reconfigured to make sure that every member of our community can have access to these spaces. I'm going to switch now to innovation and entrepreneurship. When you ask our students, are they interested in learning about entrepreneurship and making? Most of them say yes, right? I'm not surprised. This is what many of them came to MIT for. But we have to do the nerd work and collect the data to show that this is true. One of the things that we've done at Project Manus, and this started maybe 5-6 years ago, is I ran into Bill Aulette. He's a professor in Sloan, and he runs the Martin Trust Center, which is analogous to the work that I do. I do work for maker spaces and trying to facilitate making across campus. Bill does work to bring people together from School of Engineering, School of Science, the business school, all the other schools on campus to help create teams and teach our students the innovation and entrepreneurship process. Bill's a great guy. He's a fantastic person. He and I have been collaborating for some years. We, about 5 years ago, started traveling around the nation looking at different schools, trying to figure out who was doing entrepreneurship right, who was doing making right, who was doing them both together right. And we found that not many people were doing both of them together correctly at the same time. So Bill and I launched a variety of different programs to help make MIT better at this, but then also to help share this with other people across the globe. One of those initiatives that we started up was the ProtoWorks. It's a makerspace inside of the Martin Trust Center where they have laser cutters, bandsaw drill press, everything that they need to be able to build rough prototypes of ideas, all the way up to $100,000 3D printer that does some pretty fantastic high resolution prints. And then once they've proved out that idea, there's a partnership with another engineering makerspace where they can go and, for example, build things out of metal if they need to, or get access to chemistry, for example, if they're doing any biotype or chemistry type parts of their innovation. And with Bill, we've done some amazing things. The ProtoWorks is just one of those examples. It's a small space, well thought out, though it has a lot of impact. And every year in the business school, we use that space, I should say in the Martin Trust Center, we use that space to teach a class called Introduction to Making. It's open to engineers and it's open to graduate students in the Sloan School. Every year we have 3 times as many students that want to take that as we can accommodate. This is really the on-ramp for most of these students, and the vast majority of them are the Sloan, the business students. It's their first exposure to being able to make things, and it really gives them a great idea that when they develop a product, what are the fundamental sort of fabrication type issues you have to be concerned about, and the importance of prototyping and when you should be prototyping. To give you an idea about this, there's one team that's come out of a program called Delta V at the Martin Trust Center. They use both the ProtoWorks and then the MakerWorks, which is the engineering sister space, to enable them to build an awesome prototype. And I'm going to show you a video of this right now.
We're introducing a new era of connected strength training. We have the ability to completely reinvent what strength training means. Being one compact device, we enable an infinite possibility of different resistance-based exercises, anywhere, anytime.
We're using an electric motor to create a resistance instead of a stack of weights. So that means that with a device, the size of a big shoebox of some sorts, you can create 120, 150 pounds of resistance, and you can control how much you have.
I think for us, the idea was, one of the biggest challenges was actually to find the right customer in the beginning. Especially for us as a hardware company, we can't just go out and even if we had 1,000 customers, we would not be able to deliver that. So the idea is that you find a customer group that A, you can learn a lot from, and B, that has something else. So for us, with these strength coaches, they A, teach us a lot, and B, they're also very influential.
You can make it so that the resistance varies in different ways. So imagine that resistance increases the more you pull on it, then that ends up feeling like a resistance band, as you're pulling on a big piece of rubber, whereas there are other possibilities, such as being able to add more weight, more resistance, only as you're moving down.
And so I'm going to pass on from that right now. The video is pretty extensive. They go on to talk about later on in the video the importance of being able to work in a makerspace, the importance of being able to learn the entrepreneurship and innovation process, and really how that was important to helping them move quickly when they wanted to build these prototypes. I also thought I'd talk a little bit about recent activities. So when COVID happened at MIT, when COVID happened, MIT decided, there are ways that we could help. How do we do this? And so they came to Project Manus and they said, you all have a great idea of all the different resources we have on campus. Think about how MIT can use those resources and the people on campus and their ideas to try to make a difference in the COVID situation. Now, there are a lot of projects at MIT that are ongoing right now. I'm only going to talk about one, and the specific reason I'm talking about this example is it was exactly the combination of innovation, entrepreneurship, making, and then also some of the medical disciplines that we have here at MIT. It was the bringing together in typical MIT fashion of all the scientific and the practical knowledge you needed to do something real that made a difference. And the project I'm going to talk about is the MIT Design Face Shield. So Right, what you see here right now is a group of caretakers at Boston Medical Center. And there was a very interesting situation when COVID hit. Many of the larger hospitals, like the MGHs, et cetera, they managed to be able to find the PPE that they needed. But you started looking at, some of the smaller hospitals, some of the veteran VAs, some of the elder care facilities, and then some of the smaller hospitals, for example, the catch-all hospitals like Boston Medical Center, and they were in a much different situation. So the task for us was to figure out what is it that what could MIT do that would really help them? And there are two ways that you can make a difference during COVID. One, with respect to PPE. One is to make new PPE for people. And the second is to help slow down the rate at which PPE is being used. Now, we all have heard a lot about masks and their importance. What just so happens, the face shield, so these plastic parts that you see over these folks' face, and I'll get you a better image of this in a minute, they help to protect the mask underneath. So if somebody's coughing or sneezing, they keep those virus particles from contaminating the mask. So it slows down the burn rate of mask, and it also protects the user's face. This is a video that's going to talk about the process whereby we came up with it.
I'm not allowed to walk around the hospital without this mask, and I'm given one for the whole day.
When we were sitting around examining what is it that MIT can do to make a difference, what could we get done rapidly in time to address the need.
So it starts out as a flat sheet and then is folded up so they can use it whenever and wherever they want.
People that are caring for others. It also protect masks, and we all know that masks are in short supply. And it was really an example of what we do at MIT. We employ the things that students learn in design classes, manufacturing classes, like 2008. And to be honest with you, we went from idea to sketch to calculations to CAD and fabricating this thing in less than 2 hours. And I'm happy to say that this project has been scaled up to mass manufacturing. MIT has partnered with the manufacturer to donate the first 100,000 to the local Boston area and other hard-hit areas across the country.
This is what we were made to do. This is what our community was created for, to harness science, engineering, and technology to improve the human condition.
I have to tell you, at MIT, whenever we turned to people and said we needed help, everybody said yes. So many people helped with this project. All the way from the vice president of finance office when we had trouble finding plastic because everybody was buying it to make face shields, to the folks that work in the Institute for Medical Engineering and Science. You saw Professor Elazar Edelman. He was the first person. He was talking about the mask he has to wear when he goes to work in the hospital. He works at Brigham and Women's in the intensive care. He's a critical care cardiologist. And he and I teamed together to work on the face shield. He was instrumental in being able to get us into the hospitals to show them the design, have them try them out. Within the span of about 5 to 7 days, we went through 28 iterations on that face shield. So I want you all to sit and think about that for a minute. In that video, you saw some paper versions of it. That design started out in a meeting of people at Project Manus when we were thinking about ways to make face shields. I then took it home and I printed that on a piece of paper, cut out the design idea we had, folded it up, it looked great, went downstairs to my laser cutter in the basement, cut it with help from my son and daughter, and made the first scale prototype. And you may not have noticed it, but my daughter was in there modeling the very first face shield prototype. So within the first few hours, we had those prototypes. And then what did we do? We had to get on campus so that we get access to the larger laser cutters. And we went to the Deep and the Metropolis, right? We used the skilled staff in those areas to build the prototypes. And then every day we were shuttling prototypes to the different hospitals, to, for example, Cambridge Fire and EHS. We had surveys where we get feedback on that. So we had the combination of innovation, knowing how to make and build things, combining it with a real need, and all the medical professionals that need was meant, that have that need. And in the span of a week, 28 different iterations, so we got to the point we were sure it would do what it was needed to do. And then we went from a Friday afternoon, by Tuesday morning, we had ramped up to high volume manufacturing at a local die cutter. So those maker spaces, they did what they needed to do. They helped us take an innovative idea, turn it into prototypes that we could use for validation, and then we passed it off to mass manufacturing. It's a great example of the way things like this get done at MIT. And it was the maker spaces that the class of 1960 helped stand up that made it possible for us to do this. As of this date, we've donated between MIT and Polymer Shapes, our manufacturing partner, 105,000 to local hospitals. We sent some to Louisiana, to California, to Iowa, where they have issues with meat packing plants, to Native American nations that have been particularly hard hit, and to elder care facilities across the nation. As of today, over 750,000 face shields have been created and then sent to people that need them. So I'll end my talk with this, and I'll just reiterate and say, the class of 1960, really have to say thank you to you, because the gift that you gave us enabled us to help grow the student base in the maker spaces, to help them grow, to help them have leadership and ownership. It helped point the way to have making done in the future of MIT, and it supported some critical innovation and entrepreneurship programs that we've been developing to figure out how to integrate making and entrepreneurship correctly for the future at MIT. So that ends my talk. I've been very happy to be here. I am very happy to answer any questions you might have.
Professor Culpepper, thank you. If we were all in attendance here, we'd be applauding and celebrating you. So thank you for sharing that. The first question that came up, and since we have a lot of alumni that might be tuning in, are any maker spaces available to alumni? And along those lines, has it been considered, whether by application or cost, has that come into consideration?
Sure. So there are some maker spaces, you know, if COVID had never happened, I would say there are some maker spaces right now that are open to alumni. The Glass Lab, where people learn how to do glass making, there are some opportunities for alumni to work there. The Hobby Shop, alumni are able to work there. The Metropolis and the Deep now enable alumni to use them. And there are probably a couple others that I know Miters, for example, does this. So some of them are available. If people are interested in getting access to these spaces, I'm your one-stop shop for that. You can contact me, and then I can find the appropriate space for you and then lead you to the right person to get you in the door. Many of these, and it's just a practical matter because of the tax-free nature of MIT and the way that federal laws are, you know, many of these spaces end up having either a subscription model where you pay almost like a gym fee to be able to use the facility, or you volunteer your time. For example, the MakerWorks is another facility. Alumni have access to that space if they volunteer their time to become a mentor and help to run the community as space, and then also to train other people.
Thank you. The next question comes from a 2010 graduate from the islands of Hawaii. What kind of partnerships do MIT Makerspaces have with local area schools and industries?
So I'm assuming you mean like K through 12, maybe community colleges, et cetera.
Yeah.
There's a lot that's going on at MIT, and that actually is run out of the Egerton Center. Like I said, my job is to help facilitate making it at MIT, and one of the great centers of making excellence at MIT is the Egerton Center. They actually have a staff member and an entire program devoted to K through 12 type making. It's run by Diane Brancazio. She does a fantastic job. She has a cadre, or I'll call it a portfolio, of classes that high school teachers can take to learn how to build maker spaces and then how to make the best use of those maker spaces. Now, with respect to people coming on campus from local schools, there are some programs where we have students come to work in maker spaces for a very short amount of time, basically to get them interested in STEM type activities. Those are much less, I'll say, widespread in terms of their in terms of how much activity is going on, compared to Diane Brancazio and the Egerton Center, you know, their programs to reach out to schools to help teach them basically how to do making themselves. It's had a lot of impact here locally in the eastern part of Massachusetts, and I know that Diane gets questions from all over the world. in terms of how to do these sorts of things. The Egerton Center's done a fine job in this respect.
Thank you. And my next question focuses more on students in this COVID-19 environment. First, with the current environment that we're in of remote work, R&D, and education, and people being at home, what are your thoughts on makerspaces being open and who has access to those? And then kind of a part two is, how can students stay busy while sheltering at home?
It's almost like I asked this person, it's almost like I paid this person to ask this question. About 2 weeks ago, Project Manus and EHS, so Environmental Health and Safety at MIT, many people think of these folks as the safety police, but they're not. They're big advocates for making. We teamed up because we were hearing from students that they weren't sure if they were going to, come to MIT in the fall because they were so looking forward to designing and building things and were just missing that if they were going to be remote or partly remote. Long story short, we teamed up and we came up with a system that has just recently gone through, the cursory approvals through legal risk management, the Vice Chancellor's office, that enables students to do making at home. So whether it's for a class or research project, et cetera, there's now a framework that's going to be put in place, actually to go live Tuesday, that makes it possible for students at home to build the things they need, as long as the faculty members they're working with can get them the tools that they need. And it operates on a 4-level system. So there's green, yellow, orange, and red. So if a tool has been designated as green, the students can go ahead and use it whenever they want. So for example, soldering iron, vinyl cutter. If it's a yellow light tool, for example, hot wire cutter, they have to go through and go through a checklist to make sure that they can do everything safely. If it's an orange tool, for example, a jigsaw, it's a little bit more hazardous. They go through and develop a safety plan, and then they discuss it with people in Project Manus and EHS, and then they can get cleared to use the tool. And then there are also red tools. For example, tools we definitely know we don't want people using with making off campus. So for example, some hazardous chemicals, those sorts of things. So that's the first piece of the pie, is that if students are going to be off campus, we should have a way to make sure that they can do their MIT sponsored making and then make it easy for them to find ways to get approval. That new system does exactly that. With respect to opening the spaces, there's still so much that's unknown about COVID. And you're talking about people running these spaces, the technicians, they're not medical experts. They're very concerned about the students. The students are very concerned. And so we're being very cautious in terms of what we do with respect to reopening. The first phase will be reopening with respect to need for research. So mostly graduate students. That'll probably happen over the course of the summer. With respect to undergraduates, it's yet to be determined. We still don't know how many undergraduates we'll have on campus in the fall. I have to say, I've been on meetings in the morning where the administration and many other people at MIT are discussing how to do this, how to open the campus back up. And it's a very thoughtful process they're going through. It's a bit early for me now to say what will be happening with makerspaces and undergraduate students, or makerspaces for social purposes in the fall. But my guess is that they may be open on a limited availability, but it's not possible to know. I think the key in all of this is going to be making sure that people that run those spaces know how to run them safely. They already know all the physical hazards with machines, et cetera. But how do you have to change the layout of a makerspace so that you can maintain social distancing? A lot of making, specifically if you're going to be trained, it's very difficult to train somebody on a machine if you have to maintain 6-foot distance from each other. A lot of these sorts of issues we're hashing through right now to figure out what it is that can be done and can be done safely, and also make it so that the people that run these facilities feel comfortable with the new way that they have to be run. So not really able to answer that definitively, but my hope is in the fall they'll be able to open on a limited basis.
Thank you. And our final question for you, Professor Culpepper. First, is it possible for alumni to visit makerspaces? And along those lines, what are the options or best courses for alumni to support makerspaces at MIT? Okay,
so let me talk a little bit about the generalities in terms of makerspaces. Most makerspace work at MIT, I would say, is not class-based. There is a lot of classwork that gets done, There's a difference between classwork, class-based making because it's compulsory versus personal making or making for research purposes. You've elected to do research if you're an undergrad. If you're doing your own personal making, you've elected to do it. And those are typically, in my experience, the experiences that our students need to have to round out their MIT education, right? Every university in the United States now has classes where you have to make things, and you go to the shop or the makerspace. So that's not what defines MIT from everybody else. It's the students wanting to go to the spaces outside of the compulsory activities. And so you find a huge amount of traffic to these spaces just for other purposes, whether it's people starting companies, whether or not it's people building presents for friends, for a wedding, something like that. So there are multiple ways to support maker spaces. Project Manus through Resource Development has a fund wherein people can support general making at MIT. So this would be making for any purpose whatsoever. It could be research, education, classwork, etc. Now, if somebody wanted to support specific classes, the best thing to do is to contact us and let us know, by us I mean Project Manus, let us know what kinds of classes you're particularly interested in. Are they aerospace, mechanical, chemical and biomaking? And we can make the right connections because it's been our job to have the relationships with the people that run these spaces and the folks that teach these kinds of classes. Now, as to whether or not alumni can visit the spaces, absolutely. If someone's coming to campus and they wanted to check out a biospace, MIT now has a new biomaker space and has a biomaker community surrounding that. If people wanted to do that, they just have to contact me and we could put you in touch with whoever you wanted to visit.
Thank you, Professor Culpepper, and thank you, alumni and friends, for attending today's virtual event. We wish you wellness and safety in the days ahead and look forward to seeing you again before too long in person or virtually. Programming note, there's more programming here at MIT. Stay tuned for talks by faculty, tech challenge games, and various class and living groups events later today. Professor Culpepper, again, thank you so much for your time.
All right, and thank you again to the class of 1960. We really appreciate all your support. Special shout out to Barry. He's been great in helping us along as well. Take care and be safe.
Thanks for joining us. And for more information on how to connect with the MIT Alumni Association, please visit our website.